Hi, welcome to another Algebra 1 video. In this video we're looking at section 4.2, which is the point-slope form of linear functions. In this video we will learn about the point-slope form of all linear functions. We will learn how to write equations using a point and a slope. And finally, we will also learn how to write equations when you're only given 2 points. So let's begin talking about what the point-slope form of a linear function is. From the wording of the title itself, point-slope form, you may know that the point-slope form of any linear function consists of two things, the point and the slope of that function. So let's say that you were to graph some random function in which you didn't know what the points were. And let's say that you represented a point on the graph with x1, y1. Now for our second point over here, I've marked x, y without the subscripts. So this would be our second point on this graph. And we know that we can find the slope of this line by taking the differences in the changes in x and the changes in y from those 2 points over here. So let's find the slope of this line that I have graphed. We know that the slope of any function is its change in y over the change in x, which would equal the change in y, which is y minus y1, over the change in x, which would be the difference between the x and the x1 over here. So we would get x minus x1. And with the slope, we can see that we have incorporated the 2 points x1, y1 in these two parts. And we have also incorporated x, y with this x and the y over here. And since we know that slope of any function is denoted by the letter m would equal y minus y1 over x minus x1. So now let's just do some algebraic manipulation on this formula. Let's say that you multiplied each side of this function m equals y minus y1 over x minus x1 by x minus x1 on each side of the equation. If you multiply x minus x1 on each side of the equation, then on this side x minus x1 would cancel out with the x minus x1, and then you'd just be left with m times x minus x1 equals y minus y1. And then formally you can rewrite this function as y minus y1 equals to m times x minus x1. And this equation is actually the general equation for the point-slope form of any linear function that you graph. So we can see how this point-slope form y minus y1 equals to m times x minus x1 can be derived from the slope formula y minus y1 over x minus x1. In this case, x1 and y1 that I have in this equation are actually parts of the point x1, y1, which I discussed earlier was part of the point-slope form. And the remaining parts of your equation are this x and the y. This x is a variable which is going to be your independent variable for this equation, and the y is going to be your dependent variable. Now that we know how to represent a function on a graph with y minus y1 equals m times x minus x1, which is also your point-slope form, let's solve some questions in which we're given a point and a slope and find the point-slope form of that function. So before starting with anything, let's first write down the formula for how we will solve this function. We know that the point-slope form is y minus y1 equals to m times x minus x1. So I've marked the y1 and the x1 in the red, and we know that the x1 is part of the point, so our x-coordinate 1 will be our x1, and the y1 will be our 2, which is our y-coordinate for this point. And we're also given that m equals to 2, so the slope on this function will be substituted with 2. So let's begin substituting and see what we get. We know that y is going to remain there as it's our dependent variable, minus y1, which is 2 in this point, equals to m, which is 2, times x, which is our independent variable, minus x1 with the subscript, and our x1 in this case is 1. So the function that we get in point-slope form, given these two constraints, m equals to 2 and the point 1, 2, is y minus 2 equals to 2 times x minus 1. We're given that m, or the slope, is equal to negative 5 over 4, and we're given the point in the form of x1, y1, negative 3, 5 over 4. Now I'd like to ask you, how do you think you'd go about solving this question to find the point-slope form of this function? Well, like the previous question, you can begin with writing down the formula, and then you can begin substituting the values. So there's my formula, y minus y1 equals to m times x minus x1. In this case, we know that the green y and the green x, so we know that we won't substitute values in these variables. On the other hand, we have y1 and x1 in the red. We will be substituting these values with negative 3 and 5 over 4, respectively. So the point-slope form for this function would be y minus y1. In this case, y1 is the y-coordinate of this point, so 5 over 4 will be y1, which will equal to the slope, which is given as m equals to negative 5 over 4. So we can substitute this m with negative 5 over 4 times the x variable, which we will not substitute with any number, minus x1, which is negative 3, which is the x coordinate of this point. So we can multiply this negative over here by negative 3, and then we can simplify this to give us y minus 5 over 4 equals to negative 5 over 4 times x plus 3. And there you go. This is the point slope form for this function, given that the slope is negative 5 over 4 and the point negative 3 comma 5 over 4. Now that we know how to find the point slope form of a function when you're given the slope and the point, let's see how you'd find the point slope form of a function when you're given 2 points and you don't have the slope given. We know that the point slope form constitutes of the point and the slope, so we will have to find the slope with these 2 points that are given. Before we go about finding the slope given these 2 points, let's do a visual representation of these 2 points on a line. On this green line graphed, let's say that this point over here is the point 2, 3, and this point over here is negative 3, negative 4. And we know that by using the change in y and the change in x, or the y minus y1 over the x minus x1, we can find the point slope form of the function. To find the slope between these 2 points, we know that we can use the slope formula denoted by the letter m, which equals to the second y minus the first y value, all divided by the second x value minus the first x value. Let's say that the point 2, 3 is given by x1, y1, and the second point is given by x2, y2. So let's begin substituting values in this formula and see what the slope m turns out to be. We know that the change in y is represented by the difference between the y values of these 2 points. In this case, we know that we have defined y2 to be negative 4 and y1 to be positive 3. So when we take the difference, we get negative 4 minus 3 divided by the change in x. To find the change in x, we know that we have to take the difference between the x coordinates 2 and negative 3 to find the change in x. So our change in x would be x2, which is negative 3, minus the x1, which is positive 2 in this case. And then we can simplify this to get the m value. And it turns out that the gradient or the slope is equal to 7 over 5. So we have found the first component of the point slope form, but we have come to a dilemma in which we have to select a point in which we will use to find the point slope form of this function. We know that the point slope form is given by y minus y1 equals to m times x minus x1, where we know that the y and the x are variables and we will not be substituting numbers into these variables, but we will be substituting numbers into y1 and x1. So our point slope form would be y minus y1 equals to our slope, which is m, 7 over 5, times x minus x1. So we have found the slope right now, but we don't know what the y1 and the x1 would be. We can find the y1 and the x1 by picking one of these 2 points and substituting the y1 and the x1 from these values. So let's say that you wanted to pick 2, 3. If we pick 2, 3, then we know that y minus y1, our y1 would be the 3 over here. So y minus 3 would equal 7 over 5, which is our slope, times x minus x1. Our x1 in this case would be positive 2. And this is how you find the point slope form of any function when you're given 2 points. Now one thing to note is that you could also write this equation given the second point negative 3, negative 4 instead of 2, 3. So let's do that and see what the second point slope form of this equation would turn out to be. So we know that y minus y1 equals to m times x minus x1. And in this case, y minus y1, our y1 would be negative 4, which would equal to the slope m, which is 7 over 5, times x minus x1, which in this case is negative 3. And then we can simplify this, so we get y plus 4 equals to 7 over 5 times x plus 3. And this is an equally valid form, the point slope form for this function, just like this one is. So you could use either one of these. And this is it for section 4.2. Leave a like if you found this video helpful and you understand the point slope form and its various applications. Subscribe for more videos in the future, and I'll see you in the next video. Thanks for watching.